Section 4.3, right triangle trig. So let's jump right into the examples here. Oh, and welcome to second semester. So now we can leave most of pre-calculus behind, take some of it with us, not a huge amount, and just journey into something that's completely different and brand new. So we want to find the exact values of the 6 trig functions that were introduced in your notes, and we're given this triangle, and we're given theta as well. So what we need to do to be able to find all 6 trig is we have to find all of the sides. So right now it looks like I have 2 of the legs, but I'm missing the hypotenuse. So I'm going to do real quickly is just go through and calculate what the hypotenuse would be using the Pythagorean theorem, something that you learned back in geometry quite a while ago. So if we go through and add those together, I'm going to get c squared is equal to 289. So when I square root that, it looks like c is going to be equal to 17. Now I know this kind of sounds silly, but you really do need to keep in consideration the hypotenuse on a right triangle is always going to be larger than any of the other sides. I know that's something that you know. Just keep that in mind when you're going through and doing these calculations as well. Alright, so let's go ahead and jump into the 6 trig. We're going to use theta as our reference angle. So I like to go through and do the original 3 trig first. So I would do sine, cosine, and then tangent. Now remember that sine is opposite over hypotenuse, so taking a look at this, let's go ahead and identify our sides here. From my theta, my 8 is going to be the opposite side. I know that across from the box, or the 90 degrees, that's always going to be the hypotenuse. So again, if it helps to identify these, at least in the beginning till you get used to doing it again, I'd recommend it. And then by default, the one that is left over is going to be the adjacent side. You'll notice that the adjacent side is always the side trapped between the 90-degree angle that was given to you in the corner and the theta that was given to you. Okay, now that we have them identified, we can go ahead and set these up. So sine is going to be opposite over hypotenuse, which is going to be 8 over 17. If that fraction could be simplified, you are required to do so. Please don't turn it into a decimal, though. We do want the exact values here. So there's our sine. Let's move on to our cosine. Cosine is going to be adjacent over hypotenuse, where our adjacent side is 15, hypotenuse is 17. Again, if it can be simplified, you must. And tangent. Tangent, based off of our picture, is going to be opposite over adjacent. The opposite side is 8, and the adjacent side is 15. Okay, now that I have my original 3 trig, it's at this point that I then go to the reciprocal functions, and I line them up with who they belong to. So I know that the sine theta is a reciprocal function for cosecant, so I'm just going to put them right next to them over here. Assuming, now, I'm kind of gambling here a little bit, I did make sure to go a little bit slow when it came to my sine, cosine, and tangent because I want to use those answers. I know that sine and cosecant are reciprocals of each other, so all I have to do is look back at my sine answer and flip it over. So the 17 now goes on the top and the 8 goes on the bottom. Or you could go back to the picture and use the formula for cosecant. Alright, for cosine is going to be secant of theta. I'm going to do the exact same thing. I'm just going to take that answer from cosine and flip it over. Also, for tangent, I'm going to use cotangent, reciprocal, flip it over. There are my 6 trigs for the first slide. Alright, moving on. We want to sketch a right triangle corresponding to the trig function and find all remaining trig functions. We're going to do quadrant 1 only for now. We'll go ahead and venture out soon, but for now, just this one. So I'm going to do the sine theta is going to be 5, 6. Alright, so let's identify what this really means here. I know that sine, by definition, is going to be opposite over hypotenuse. So my job is to draw a triangle where the opposite of the angle is going to be 5, and the hypotenuse in the triangle is going to be 6. Alright, so let's go ahead and draw a picture here. First quadrant only. Okay, so here's my little axis, and I have a whole bunch of little pictures that I draw. I find them helpful, so I'm just going to go ahead and follow along with it. I want my reference angle to go back to the x-axis, and I'm not going to draw the most accurate picture here. I just want it in the first quadrant. There is my theta, and so opposite that I'm going to have a 5, and then the hypotenuse I'm going to have a 6. Now it's just like the previous problem. So what I need to do is I need to do the Pythagorean theorem to find the side that's missing. Notice this time it's a leg that's missing. It is not the hypotenuse this time, and we can get rid of some of this. We don't need that. So go through and do the exact same thing that I did. So it's going to be a squared plus 5 squared is equal to 6 squared. If I go through and solve this, it looks like I'm going to get a squared is equal to 11. So a is going to be equal to root 11, which if it could be simplified I must, but it can't. So I'll just go ahead and put it here. Now I'm ready. So get all of my 6 trig out. I realize that sine was given to me, but I need to find cosecant later, so I'm going to go ahead and just list it down here as well. So I know that sine theta, which was given to me as 5, 6. Okay, cosine. Taking a look back at the picture, it looks like the adjacent side this time is going to be the root 11, and the hypotenuse is going to be 6. If that could be simplified, you must, but root 11 is prime, so there's no way to simplify that root, and there's no way that you can get those two together because one's inside of root and the other's not. Okay, moving on to tangent. Tangent's going to be opposite over adjacent, which is going to be 5 over root 11. Alright, this needs to be rationalized. So to do that, I'm going to multiply by root 11 over root 11, which is really just 1. I'm just making it look the way I want it to. So this is going to be 5 root 11 over 11. Alright, so tangent doesn't look awesome, but that's what it is. Alright, now that I have those listed, I'm going to go ahead and do the reciprocal functions. So right next to sine, I'm going to put cosecant. And I'm going to go back to the sine, and I'm just going to flip it over. So cosecant's going to be 6 over 5. I'm going to do the same thing with cosine and secant. I know that cosine was root 11 over 6, so now it's going to be 6 over root 11. Do the exact same thing, rationalize top and bottom, multiply by root 11. So it's going to give me 6 root 11 over 11. If it can be simplified, I must, but it can't, so I move on. Cotangent theta. I'm going to do the exact same thing. I'm going to go back to tangent. However, I want to be smart about this. I have multiple stages of tangent that I could take a look at. I know I want to find the reciprocal of it, so I go back to the point before I rationalized so that if I were to flip it over, I wouldn't have to really do anything. So I'm going to look right here, and I'm just going to use that one. I'm going to flip that over, so it's going to become root 11 over 5. Notice that based off of the stage at which I grabbed tangent, I don't actually have to do much work other than flipping. Alright, let's move on to the next one. Same idea here. So I think I'm going to set this up a little bit, and then I'm going to highly recommend that you pause, but let's kind of get this going a little bit. I'm not a big fan of using the new reciprocal functions. I'm far more comfortable with the original 3. So I think that's what I'm going to do. I'm going to turn this one into something I know. So I'm going to put a 1 underneath this so I can see that it's a fraction. And I know that the reciprocal that goes with cosecant is going to be sine. So now that I know sine theta and cosecant are reciprocals, all I have to do is take that 3 and flip it over. This is 1/3. Now that I've done that, this problem looks exactly like the previous problem. So at this point, I am going to pause, fill in all of the work. So I would pause if I were you. Draw the picture, do all of the work, and then check your work against mine. So I decided to stop midway because I thought there was something you might need to see here. So I took my sine, flipped it over, excuse me, set up my picture, and I did my Pythagorean theorem. When I did that, I'm going to get the square root of 8. So this is the first time we actually have to simplify. The square root of 8 can be simplified. Remember that 8 is 4 times 2, so it's actually going to give us 2 root 2. So I've got my triangle set up. You'll notice that I already wrote down my sine because it wasn't really given to me, but I've already found it. So now I am going to pause again. I'm going to go ahead and set up all of my other trig. Make sure that you rationalize. And when you're done with all of the other 5, go ahead and turn your pause off and let's see if we match. So let's see how you did. So compare your answers to mine. You'll notice that I have a couple of different solutions written down for tangent and secant. So just to be clear, the answers are going to be the final ones after the rationalizations happen. So for tangent, it's going to be the root 2 over 4. And for secant, it's going to be the 3 root 2 over 4. We don't need to see that you're rationalizing, but we do need to know that you have rationalized. So make sure that your final answer is as cleaned up as possible. Let's take a look at the next slide. Alright, so now we've got an application problem. So this matches the application problem in your notes exactly as you had it. There's the picture as well. So now all we need to do is figure out how wide the river is. So what I'm going to do is I'm going to take that picture and I'm just going to draw it a little bit bigger so I can take a look at it. Just the triangle. I don't really care about the lake being in there. Okay, so there's the 100 that was given to me. Know that that's a right angle in the bottom. I'm trying to find the width, which goes there, and then they gave me this angle, which is going to be 58 degrees. The only thing I need to do is be able to identify what trig I have, and it looks like tangent to me. So I would do tangent of the angle that was given, which is 58, and that's going to be opposite over adjacent. To solve this, I'm going to cross multiply. So the exact length would be that, or exact width. So this is exact. However, that really doesn't mean much to most people, so we do want to get a decimal approximation here. So I'd grab my calculator, type this in, and I'd approximate it out to, I always go out to 4 to make sure that you're accurate to 3. So if I type this in, I get 160.0334. So I would say the width is 160.0334, and I believe this was in feet. Alright, there's my application problem. Now, I know that your notes probably stop there, but we have one more slide that we need to go through, and this is just using your identities a little bit. So let's take a look at question number 4. So first semester when we started doing stuff with logarithms, we did a proof at that point, and I kind of kept harping on you need to make sure that you only pick one side, you only work with one side, and you carry the other side down with you. We were getting you ready for this. Now we're just practicing. This will eventually become an essential skill, but not this chapter. So I normally like the side that has the most stuff, so it gives me more to kind of play with. So if I take a look at question number 4 here, and to me it looks like the left-hand side, the cosecant and the tangent, have more stuff. So I'm just going to go ahead and use what I know about cosecant. Let's see. Cosecant's a whole bunch of stuff. Let's do the reciprocal functions and see if that gets me somewhere. So I know that cosecant is the same thing as 1 over sine. So let's replace that with 1 over sine. Now I'm going to show all of my steps here. Definitely more than I need to, but I don't want to lose you people. So now let's do some sort of a replacement here with tangent. I know that tangent is sine over cosine, so let's do that one. I see that the sines cancel, so I get a 1 over cosine. And that's actually true, because the reciprocal for cosine is secant. So there's my proof. Notice that I just used identities to get the left and the right hand side to match. I carried down the side that I didn't touch. That's important. You want to make sure that every line of this is accurate. Okay, let's take a look at question number 5. Again, we're kind of building up on this. So let's see. I have a whole bunch of stuff on the left-hand side. But it's trig that I'm used to, sine and cosine. But I also on the right-hand side have cosecant and secant. So 2 different trig, kind of like the left, 2 different trig. So I think I've got a whole bunch of different choices that I could go through here. So, I don't know. Let's try the left-hand side and just play with it a little bit. Alright, so I see 2 fractions. I see that plus sign, but there's no plus sign on the right-hand side. So I need to turn plus into multiply, which means I need to pull these 2 fractions together. So let's pull these 2 fractions together. Well, I need to get a common denominator. So for the first one, I think I need to multiply by sine. So let's multiply top and bottom by sine on the first fraction. but then I still have the sine and the cosine that were there to begin with. Alright, plus, still not one fraction. I'm working on it. I'll get there. Alright, now we need to do the same thing here. So I have to figure out, to get the sine over, to get the cosine sine in the bottom, this one needs a cosine. So I'll multiply cosine top and bottom. And then remember to take back with you what you started with. So again, I'm just getting a common denominator here. And then I'll carry down the right-hand side. Alright, so it looks like when I multiply this first one, I'm going to get sine squared. Now keep in mind that you're squaring the function sine. You're not squaring the theta. So notice that the squared is on the sine itself and not on the angle. Doesn't make any sense to put it on the angle. Okay, plus, then I get cosine squared on the top over here. Alright, now I've got that common denominator, sine cosine. And that's going to be equal to, just carry down that side with you. Alright, oh, I see the most important trig identity that I'm going to use. Sine squared plus cosine squared is 1. Now all the other ones are important. I don't want to knock the other ones, make them take a back seat to this, but that Pythagorean identity of sine squared plus cosine squared is really the foundation for a lot of what we're going to be doing. Alright, I think I'm close. I see reciprocals here. Let's just rip them apart. So, got 1 over sine theta times 1 over cosine theta. I'm just ripping those two apart. It's multiplication, so I can just show them separately. And I think I'm in the home stretch. 1 over sine theta is cosecant theta. And then 1 over cosine theta is secant theta, which is exactly what I have on the other side. So again, just a little tiny bit of practice and introduction to proofs. It's not an essential skill yet.